Welcome to the deep dive. Ever wonder how software makes seemingly complex tasks, well, maybe less complex?
hmm
Today, we're going to unpack a really perfect example, automating student grading using C Sharp.
Right.
We've got the inside story of a teacher's assistant who's taking their grading app, to the next level.
Yeah, moving away from just like a pile of individual scores.
Exactly. Towards a more streamlined system using things called arrays and loops and conditional logic.
Yeah. And our mission really is to see how these sort of fundamental building blocks of code, how they come together to solve a real-world headache.
Definitely. We'll be using excerpts from Learn C Sharp Podcast 26.4 and if elseif else structures to process array data.pdf as our guide.
Think of it like peeking under the hood.
Yeah.
An application getting a major upgrade. We're not just looking at the new features, but really trying to understand why they made the choices they did.
And for you, the learner, this isn't just about coding jargon. This deep dive is really about seeing core principles in action. We're talking about how you can organize lists of information that's your arrays,
Right.
how to efficiently go through those lists and do something with each item. That's where these Foreach loops come in, and how to make decisions within a process based on certain conditions. Those are your if else statements.
Exactly. You'll see a basic setup kind of morph into something
Yes.
much smarter, much more adaptable.
Yeah, maybe you'll even see a spark of how these ideas could simplify things you deal with, managing data, automating tasks, or even just satisfying that curiosity about how software works.
Well, what's really telling is where this application started. It was very, very manual.
Oh, yeah.
Yeah. Imagine tracking like 5 different exam scores for 4 students, Sophia, Andrew, Emma, Logan. Each score in its own little separate container, its own variable.
Right.
Then more separate containers to hold their total scores, their averages.
Mm-hmm.
And then finally, someone actually looking at that average and manually deciding the letter grade. The output was just a basic formatted report.
That sounds like a recipe for a lot of clicking and, let's be honest, probably a few errors creeping in.
Oh, absolutely.
Ugh.
Especially if you had a whole class. Think about the repetitive work involved.
Yeah.
And that's really the central problem this update is tackling.
Yeah.
The teacher wants a system that's much more flexible, less prone to those manual errors.
Makes sense. So what were the specific goals?
Okay, so first off, get rid of all those individual score variables. Use arrays instead to store not just the student names, but all their assignment scores, including any extra credit they might earn.
Okay. Arrays for storage. Got it.
Second, use a Foreach loop as the main kind of workhorse, automatically going through each student one by one.
Right, a Foreach loop. It's like having a worker who just takes a list and does the task for each item, right? You don't
Yep.
have to tell it how many items or where they are.
Precisely. It just handles each one in turn.
Right.
Then, inside that main loop, there's going to be an if statement. Think of it like a traffic controller, making sure the application knows which student it's currently dealing with, and therefore, which set of scores to actually grab.
Ah, okay.
Following that, another Foreach loop jumps in. This one adds up all the assignment scores for that particular student.
Right, summing them up.
Yeah. And naturally, the way the average is calculated needs adjusting based on this new total.
Now, this next part sounds interesting, automating the letter grades. No more manual lookups.
Exactly. They're implementing what's called an if-else-if-else structure. Basically a set of rules.
Like, if the average is in this range, it's an A.
Precisely. If the average falls within this range, then the grade is this. Otherwise, if it falls in this other range, the grade is something else, and so on down the line, like a flowchart for grading.
Nice. Takes the guesswork out.
And a really practical addition is how they handle extra credit.
Oh, yeah. How does that work?
So the rule is any extra credit scores contribute to the final grade, but they're only weighted at 10% of a regular exam score.
Okay, so they're worth less.
Right. And the application needs to be smart enough to figure out which scores are extra credit just by looking at how many scores a student has.
Oh.
Well, if there are more scores than the standard, say, 5 exams, those extra ones are automatically treated as the bonus points.
Ah, clever. So it's not just tacking on points. There's a specific value, a weighting. That adds a layer of sophistication.
It does.
Ah.
And it requires careful planning in the code. The app needs to distinguish regular exams from extra credit, apply that 10% weighting, and then combine everything for the final tally.
Right.
And the overarching goal through all this, make it scalable. The teacher needs to be able to add new students, new assignments later on
Sure.
without needing to rewrite huge chunks of the code.
Which makes total sense. Imagine rebuilding the whole thing every time a new student joins. That's really where the power of these programming structures comes in building something that can grow.
Exactly. So the key things to watch for as we dig deeper are how that initial kind of clunky code
Yeah, the cumbersome stuff.
is transformed by using arrays. Notice how these nested Foreach loops, basically, a loop working inside another one, allow for a really efficient way to process each student and then each of their scores.
Okay.
And the logic for dealing with extra credit, its specific weighting, and the automated letter grades using those if, else conditions, those are really the heart of this upgrade. They show how code can be made both smarter and more manageable.
All right, let's get into the details then. How did the teacher's assistant start this upgrade? Where did they begin?
Okay, so the first thing was tackling how the student scores were stored. Instead of all those separate variables like Sophia 1, Sophia 2, up to Sophia 5.
Right, for each student.
Yeah, repeating that for Andrew, Emma, Logan. They moved to using arrays. So for Sophia, all 5 of her exam scores now live inside a single ordered list called Sophia scores.
Okay, one container per student.
Exactly. Same for Andrew, Emma, Logan. The immediate benefit is organization. All Sophia's grades are logically grouped.
Makes it easier to read, I bet.
Definitely. And it paves the way for processing these scores using loops. It's like, taking ingredients for a recipe and putting them in labeled bowls instead of scattering them everywhere.
Good analogy.
And of course, all those old individual score variables, gone. Simplifies things a lot.
Right, so it's more structured. Okay, scores are in arrays. What's next? Automating the totals.
Yep. The original code had separate lines adding up Sophia's scores, then more lines for Andrew, and so on. Very repetitive. Now, at least for Sophia initially, this is replaced with a Foreach loop. This loop just goes through each score inside the Sophia scores array.
And adds it to a running total.
Exactly. Each score it finds, it adds to a variable maybe called Sophia sum.
Okay.
This is really fundamental shift. Instead of writing out 5 separate addition steps for every student, you now have this concise block of code, the Foreach loop, that does the same thing.
And it doesn't matter if there are 5 scores or 6, right?
Precisely. It doesn't care. That's the first real glimpse of that scalability we talked about. The code becomes much more adaptable if the number of assignments changes.
Okay, so the loot calculates the total Sophia sum. Then the average is just division.
Simple division. Divide that sum by the number of assignments, which is stored in a variable, let's say current assignments. So even at this stage, just for Sophia, the code can calculate and show her average much more efficiently.
Even just for one student, switching to arrays and loops makes calculating the sum cleaner and more flexible. It's a small change, but it really impacts the code's organization.
And that's just the foundation. The real efficiency boost comes when you apply this to all the students.
Right. How do they do that?
So the next step is creating another array, this time holding just the names of the students. Sophia, Andrew, Emma, Logan. Let's call it student names.
Oh, yeah, a list of names.
Then they introduce an outer Foreach loop. This one goes through each name in that student names array.
Ah, okay. So now we have a loop that says, for each student in our list. What happens inside that loop for each one?
Good question. Inside this outer loop, the goal is to do the grade calculation for whoever the current student is in that loop iteration.
Right.
Initially, the code we just discussed calculating Sophia's sum and average gets moved inside this outer loop.
Right.
But, and this is just temporary, it's put inside an if statement that checks. Is the name variable holding the current student's name from the outer loop equal to Sophia?
So at first, it only actually does the calculation if the student is Sophia.
Exactly. At this point, the calculation only runs when the loop hits Sophia.
That feels like it could still be a bit repetitive, right? Like you'd need similar calculations inside separate if blocks for Andrew, Emma, and Logan.
You've hit on a key point. Good programming avoids repetition. That initial if statement is really just a stepping stone. It shows how the outer loop structure works.
Okay, so how do they make it less repetitive?
The next refinement is to make the code more general. They create an integer array, let's call it student scores, just an empty container for now.
Okay.
Then inside that outer loop, that single if statement checking for Sophia expands into an if, elseif, else structure. Now, as the outer loop goes through the names, if the current student is Sophia, the generic student scores array gets assigned the actual scores from Sophia scores.
I see.
If the current student is Andrew, then student scores gets the values from Andrew's scores.
Yeah.
Same for Emma and Logan.
Got it. So inside the outer loop, for each student, the code first figures out who it is.
Yeah.
and then points this generic student scores array to that specific student's actual grade list.
Exactly right. Then, that inner Foreach loop, the one that calculates the sum, it now iterates through this generic student scores array.
Because it's just been filled with the current student's data.
Correct. And the variables holding the sum and average are also renamed to be more general, like sum assignment scores and current student grade.
Makes sense. More reusable.
And finally, the code that displays the results is updated. It now shows the current student's name and their current student grade. All those original separate output lines for each student are gone.
Replaced by one output line inside the outer loop.
Just one console, right line inside the outer loop. It processes and displays the results for every student dynamically as the loop runs.
Wow. So now the same block of code works for all 4 students. It just needs that student scores array pointed to the right data each time the outer loop runs. That is a massive leap towards scalability.
It truly is. And the next level of automation, as we mentioned, is assigning those letter grades.
Right, the if, else for grades.
Yeah. The teacher provided a clear grading scale. The update implements that using another if-else structure to automatically figure out the current student letter grade based on the calculated current student grade.
So, like, if current student grade is 97 or higher?
Then current student letter grade becomes A+, then an elseif checks the next range, maybe 93 to 96 gets an A.
And so on down the scale.
Exactly. 90 to 92 gets A, all the way down to the final else condition for anything below 60, which gets an F.
That completely removes the manual grade assignment step. The app crunches the numbers and applies the rules.
Precisely. And the final piece was incorporating that extra credit.
Okay, remind me of the rules for that.
Sure. Extra credit assignments are worth 10% of a regular exam score. They get added to the total before the final average is calculated. And the app needs to automatically spot them based just on the number of scores.
If a student has more than the standard 5 scores, the extras are extra credit.
Correct.
Okay, this sounds like it requires some cleverness inside that inner Foreach loop, the one adding up the scores. How does it tell a regular score from extra credit?
It does require a bit of logic. First, the variable holding the number of regular exams, which was maybe current assignments, gets renamed to something clearer, like exam assignments. Let's say that's 5.
Okay.
Then, inside that inner Foreach loop, the one summing scores, they introduce a counter variable. Let's call it graded assignments. It starts at 0 for each student.
And it counts each score as the loop processes it.
Exactly. It increments each time a score is processed. Then, an if statement checks. Is this graded assignments count less than or equal to the number of exam assignments, which is 5?
If it is, it's a regular score.
Right. If it is, the score is treated as regular and added directly to the sum assignment scores.
And what if the count goes beyond 5? Like the 6th score, that must be extra credit.
Exactly. That falls into the else part of that if statement. So if we're dealing with an extra score, score number 6, 7, etc., that score is first divided by 10.
To get that 10% weighting.
Correct. Divided by 10, then added to the sum assignment scores. This way, the extra effort contributes, but with that reduced weight the teacher wanted.
But the final average is still calculated based on the original number of exams.
Yes, the current student grade is still calculated by dividing the final sum assignment scores, which now includes weighted extra credit, by the original number of exam assignments, so by 5 in this case.
That's a really elegant way to handle the weighting. Just by keeping track of which score it's on in the list, it applies the right logic. And because arrays can easily hold extra scores, adding more extra credit later is simple.
It becomes really straightforward. And, to really drive home how much more adaptable this new system is, the source material shows the assistant adding even more students.
Oh, really?
Yeah, names like Becky, Chris, Eric, Gregor, along with their exam scores and some extra credit scores, just adding them to the arrays.
So update the student names array, create new score arrays for them.
Exactly. And the crucial point is the core logic, the loops, the conditional statements for grades and extra credit doesn't need major surgery.
Just needs to tell the outer loop about the new names and their corresponding score arrays.
Pretty much. A few more else if conditions get added to that structure inside the outer loop to connect Becky to Becky scores, Chris to Chris scores, and so on. But the fundamental processing structure stays the same.
And it works.
Works perfectly.
Yeah.
Running the updated code correctly calculates and assigns grades for all the students, old and new. It really shows the power of this approach for handling more data with huge code changes.
So we've really seen this application transform, haven't we? From that very manual, kind of rigid system to one that's much more automated, much more scalable, all through using arrays strategically to organize data. Foreach loops to process it efficiently,
Right.
and those if-else-if-else structures to make decisions like assigning grades and handling the specific rules for extra credit.
Absolutely. We've seen firsthand how moving from individual variables to arrays just cleans up the code, makes it way easier to manage.
Yeah.
The nested for loops give that systematic way to work through students and their assignments. The if-else-if automates grading based on clear rules.
And the extra credit handling felt really practical, automatically detected, weighted correctly.
Yeah, it shows a thoughtful approach to different assessment types. Ultimately, this deep dive really highlights how these, fundamental programming concepts combine to build genuinely useful, flexible tools for managing real-world info.
It makes you think, doesn't it? How many tasks in your own day-to-day life involve dealing with lists of information and applying rules or calculations?
Lots, probably.
Maybe it's managing a budget, tracking fitness goals, even organizing recipes. The basic logic we've explored today, organizing data in lists, processing them automatically, making decisions, could simplify those things too.
Definitely.
So what kind of information in your life, listener, could benefit from being structured and processed using ideas like arrays, loops, and conditional logic? Could you maybe see yourself taking a small, deep dive into learning a basic programming language to tackle one of those challenges? Maybe build your own helpful little tool.